link everything so we can see it. All right, so we're streaming. So, where did we leave off last time?
Not with a failing test. Okay,
No,
let's see.
here.
We renamed something.
What did we rename?
Populate board. So let's go look at that.
Well, actually, if I remember right, this whole area of the Sudoku board and stack, this feels sort of like good enough at the moment, and like there might be more interesting stuff in the other place.
Okay.
That's like a weird statement because, like, I don't know what's in the other place at all, but I feel like I now know enough about this that if we need to, we can come to it.
Yeah, no, that makes sense to me. The other thing that caught our attention was we're wondering whether Sudoku state should be its own class, whether board should be its own class. Maybe we'll learn more about that.
Yeah.
And there's a large.
Oh, yeah, we inlined stuff, but I don't think we ever pulled it out. We should pull that out. Let's pull that out.
We can? Okay.
Before we do more.
I think I have the right selection. Nope. That did not. Yeah, let me try the other kind of expand selection. Did that do better? Okay, that's
wait,
good.
There's two types of expand selection?
Yeah. What?
There's two types of expand selection?
Built into Visual Studio and the Resharper extension.
Which one was better?
I don't want to play favorites. No, Resharper was better.
All right, let's extract this. Do expand.
Sorry, just expand?
I was going to say do expand.
Do expand, okay. Do.
And the other one is do collapse. And then the last one is get viable move.
Hey, Visual Studio, whatever comment I put in the commit description, keep it there for the next time. Do move.
Actually, yeah, the do move is, it's like a maybe do move. Anyhow, good enough. Let's go to the other place and see what's going on here.
Caller.
Yeah, whoever calls this.
I'm going to close everything here.
So we come in here and we construct a board, and then we generate a board from completely unsolved one.
We had that insight last time that it starts with solution to Sudoku, and then it goes what feels like backwards to me, removing elements.
Yeah. Is that the 22?
Generate initial board from completely unsolved one. I think so. Although this notion of unsolved, like,
go into it.
Is that just wrong? Is it supposed to be completely solved one?
I think it might be.
Should we rename it?
Actually, let's just put a breakpoint on 388 and check what our data state is.
Do that right here. In fact, I didn't even just have to break into this covering test.
Oh, that's
cool. Set a breakpoint. Thanks, Remco.
Yeah, thanks. Okay, and then let's see what that Sudoku state. Not this one, the board. It's trying to print out, but it's not doing new lines, which is super annoying. Is there a way to, like, if you look in your down there, is there a way to format that so it's nice and pretty?
Here?
Yeah, that one. There, that's what I want to see.
Oh.
Hover over that again. So it's not showing me the last part, but this feels very much like a completed board.
It would be very boring if only the last two rows were empty.
Empty, yep. Yeah. So I think it's fair then. Let's rename this to generate a puzzle from completely solved. And then I'd also kind of like to know what this kicks back. So what does this kick back?
State. Stack state peak.
You just go to the end of this statement. Get down to
And,
line 413.
okay. Oh, run to here.
Yeah, run to there.
Let's see. Break.
Okay, so I want to see the board at this point too. Let's start with the board.
Okay.
Not the board. The board. The object, not the variable name. That's what I'm trying to say. Yeah. Okay. So it's modifying the Sudoku board in stack state. We don't know about the stack state, but it's definitely modifying the Sudoku board.
Mm-hmm.
But then we also have this state thing that it's returning. Can we take a look at what that state thing is? 9, 8. So this looks like it's the same thing. I'm just sort of
The
spot
zeros are the
checking here.
blanks.
Yeah, it looks like zeros are blanks, and the rest of the thing, that's not it's not very rigorous.
So it's a, I don't know what the word is. It's like a linearized, it's the two-dimensional array.
Yeah, it's a two-dimensional array, just without making it two-dimensional. Just
I'm
divide
sure
by
there's a
9
math name
kind of
for
thing.
that. Why does it care?
There's a one-to-one mapping between a single-dimensional and two-dimensional array. Is that the concept?
Yeah.
It's literally what programs do in the background, anyways. But
Yeah.
whatever. Yeah.
It turns out our memory is one-dimensional.
So we get the state back. What do we do with the state after we get it back?
So it comes here to applesauce 6. We should go look at that. State.
Yeah. Does this take the board and thing? Wait.
This takes the random. So this is after, right? Like we noticed that here it created the solution, the solved board. We should rename that to solved. And then it removed elements to look at a puzzle.
Okay.
And then I don't know what lookup structures is. We're curious about that. And then applesauce 6, we know nothing.
So
What is that?
Let's go here back to that lookup state thing because something's weird. Because okay, so like what we think. No, go up a little bit. The insight we just got is this state that comes back is the board as numbers. Right? Like we believe line 22 returns the board as numbers.
LeBron, does this program solve? Wait, does it take a solved board and then unsolve it and then solve it?
I mean, I think that's a fairly. Let's look at the output that we get. Maybe it does.
I'll just run it. So if you think about one
I think this is one of those start at the top things.
Yeah.
Okay. Final look of the solved board. So that says, hey, it looks like that. Then look at the book. So we're deleting things. And then rows. Okay, so then yeah, it looks like it is solving it. Wait, what's this 06? Is that code thing that it's printing just the board as a single digit number? Like this is the zeros?
That's what it looks like.
Why would it even do that? Unless that's like meant for like debugging purposes. Like, hey, you can copy this and pull it back in. Okay. Okay. So let's I think that is what it does. So let's sort of represent that somehow. Let's get that insight into the code.
Okay, is there anything at the end?
I mean, one of the things that's nice is if if you're working with someone who actually understands the code, you can just ask that question, or maybe they'll tell you.
What does
But
this
we don't
program
have that
do?
luxury right now. So,
Yeah.
um, yeah. So now, so if we go back to where we were, there's still this weird thing about that state. So that state, can we rename that to like board as numbers? And then if we have
Okay.
the board as numbers, why do we also have the board as characters? Like those two things are kind of the same. Are they moving together? Can you do a check for state? How do you even do that? Okay, so let's start with the board that we're passing in on line 26. Let's actually pass in the board itself.
You mean pass in
Yeah, so
this
we're gonna do
object and
pass in the object. So we're gonna do the same trick we did before. So pass in the object and the board.
do you want the rename of board as numbers?
I do like
Keep or
that.
discard? Okay.
Keep that, yeah. And let's also do that on line 30 because that like dribbles down. Yeah, so board is numbers.
Undo.
Yay, small changes.
Yes.
Okay, so we got board is numbers here.
Second, that's this one here.
And then do that one as well.
So next we say yank that. And can we change type of parameter to that?
Oh, that's nice. Is that new?
No, but it's not a refactoring. It's just
Oh, okay.
like things are still broken.
Oh, no, then let's undo that. Let's do it the safe
Okay.
way we did last time. So just add the new parameter. Because we're going to add the new parameter. Quick fix that to add it. Commit that. Then on line 34 and a half, we're going to say board equals Sudoku board stack dot state. 34 and a half, yeah. Dot board. Then you should be able to inline board on 34. Or let's change board to board 2 on 33.
What is the name of that refactoring we just did?
It's like a shadow variable
Who knows what evil lurks?
behind the shadow. No, the shadow knows. Uh, yeah, so now we can basically, no. So next go to line 35 and declare it there. So put a var on 35 and change board to board 2. That's the full shadow.
Should that be part of the previous commit?
Tomato, tomato.
Might
I
be
would
something that
have been okay if it was, but I'm also okay if
Alright.
it's not. And then now we can remove this.
We might like study that a little more and see if we can refine the recipe sometime.
And now I want to inline board on 35. And then let's go find Sudoku stack board and stack state. And I just want to, I want to see, does it change with the board as numbers? So there's a board as numbers thing that happens right above this. Go to the next one. There's a board as numbers that happens two above it. That's scary. Go next one. And this just moves it on. But there is a board change made. Look at, so let's go into change made again. Maybe just, yeah. Look up if board has, so here we have board is, so go into look if board has multiple solutions.
Can we rename this to a, was change made like that?
Yeah, sure. I like that better.
All right, where do you want to go?
So it looks like this cascades down again into 351, 352. So we have this board. So I wanna cascade it down again. So if we go back to where it is, pass in Sudoku board and stack state into here.
Oops. Are you wanting to do it for both of these functions, or?
I am wanting to do it for both of these functions, so yeah, go for it. Though we do now have whip. Well, no, things aren't even compiling right now. There we go. Okay. And then let's do the shadow here. So bar board equals board, and then set the other one to board 2. You don't want to do rename. You don't want to do rename right now. You're just manually renaming board to board 2.
Yeah, I did that.
You didn't do that on 65.
I put an underscore.
Oh, okay.
It's better too.
It's hard to see with the the curlies.
Okay. Yeah. All right. We'll do 2.
There you go.
I still like underscore, but
yeah, I can understand if it was seeable.
I want a tall underscore.
I'm disliking that we're doing this in 2 places at the same time, but I understand at the same time. Okay, so commit that. And then let's delete that. In both places. So the interesting thing about the name state, which is still a horrible name, is final state. I think that's the solve board.
Mm-hmm.
It's passing in the solve board to the solver. Go to where we the top of this.
Top of up here.
Yeah. So we generate from the completely solved board. That gives us the board as numbers, and this is the actual puzzle board, which again, and it gives us the final state,
Solved.
which is yeah, that's a better name. Can we go to generate puzzle from completely solved board? First of all, we have 2 out variables, which in and of itself should tell us that this is like crap. Like that is something that was introduced by our refactoring, right? And we should have caught it when we introduced it and said, hey, 2 out variables, that's not very good. So what is this doing? This takes the stack and the board, and then it generates initial board from completely solved one. Okay, great. So it takes some remaining digits, which is weird, which seems to just be randomly magical, and some things, and then an array, and then a position, and then a state. And then it creates a final state from the state. And the state is what? Stack state. And stack state is this. Oh man. Go go back to the whole thing we pulled out. And so this Sudoku board and stack state at the end of create the completely solved board, or construct the completely solved board. Let's put a breakpoint there and let's look at that Sudoku board and stack state.
The end of this function? Or
line
right
20.
Here?
The end of line 20. I want to get to the end of line 20 in the debugger. Okay, and then open up that Sudoku board and stack state and look at the stack state. And can we see that sort of next to the board?
Oh, a great way to see it.
No. You up to the top. That was good. Okay, so I'm going to read the numbers at the top. You read the numbers going down. 971, 623, 5,
That's as far as I can see, but yeah, they all match.
Okay. Okay, this is what I think is going on. I think that we have data in like sort of three places. We have that char array, right? And we have the stack, and we have an integer array, right? And my question now is, do they move the same, right? So what I want to do now is go to like somewhere down in applesauce. So like put a breakpoint somewhere in the middle of these steps.
Before we go do that, I wanted to look at something else. So state stack. I don't know why it's a stack. I don't know what data it holds, but the top element looks like a fully solved board.
Yeah.
It looks like the same values. And then if I go to the very end, there's 81 elements. 81
is 9 by 9.
9 times 9. Okay. And it has some values, mostly zeros. There's a 1.
Well, what variable is this?
Stack state last element. It has a single value and it's a 1. The rest are all zeros.
So what variable is this?
Stack state. So this variable here is called Sudoku board and stack state.
Yeah.
It has two members.
Yeah.
One of them is board, which we know what it looks like. It looks like that. And the other one is...
Oh my God, stack state has 82 things in it.
82.
Not 81.
That's true. It has 82.
And the first 81, we believe, is the actual board.
So this one is the fully solved board.
Yeah.
I believe that. And then if you go to the other end...
And then the very last element...
is all zeros except for
is another
single
stack.
Value right there.
It's a stack of what? Is it a stack of stack? Or...
It's a stack of arrays of 81 ints.
The second one.
I think...
No, wait. The first... Wait, what?
So I think what's happened here is when it was constructing a fully populated board, it started with a fully empty board.
Yeah.
And then it put one value in, and then it saved that away. And then it put another value in and saved that away. And so the entire history of how the board was built up has been saved as 82
things.
82 arrays.
And we think the last one is the actual data.
Mm-hmm.
Why in the world would they want the whole stack?
I don't know.
Okay. Well, let's just assume that they do, because we don't know that they don't right now. But the final state... Okay, so... Okay, but it's still the... So now it feels like we have... So we still get to this point where it's like... I feel like I want to be able to express the board like we have this int array of 81, and that's our actual data. And the char seems like it's just a way of visualizing the data, right? Um, Somehow I'd really like to remove that char thing. So let's go to our board. I'm just going to try something. We have really good test coverage right now.
Mm-hmm.
So let's
I
try
think so.
something stupid. Let's go to Sudoku board and stack state. And actually, can we, if we scroll down, the board itself here, let's make that private.
It is used outside.
Good. So let's make it private and then see what breaks. Good. And go to the first thing that breaks. We're on a commit thing. We can revert this.
There's a keystroke for go to the next error in crunch, but I don't remember what it is. Wait, hold on. Go to.
Did we write a set thing? I felt like we did in Sudoku board and stack. Do a dot there before the board. And there's
Set value.
Set value. So change this to set value candidate.
You want me to write candidate here?
I think the parameter you're setting in is candidate. I think that's what they're doing here. If we go look at set value,
Oh, I see what you mean.
It's 1 plus candidate, right?
It's going to take a row, column, and a value.
And I think that's candidate. Okay, and then no, not 1 plus candidate, just candidate.
So previously it was doing 0 plus candidate somewhere. So we're in a broken state right now.
Yeah, so but that's fine. If we go back to Sudoku board and set state, we can turn it from private to public, and we're just dealing with this one thing at a time.
Okay.
And did that break stuff, or did that still broke?
It did break stuff.
Okay, so put the plus one candidate. Yay, tests.
Cheating.
Okay, commit that. And then let's basically repeat this process. I want to get board completely encapsulated into this board and stack state thing. So yeah, same thing here. That should be set value, row, column, and digit.
0, great. That's not reassuring that sometimes it's 0, sometimes it's a 1.
No, not reassuring at all. But tests are reassuring.
Okay, that's it for.
Can you make that private now?
All right, let's try again.
No.
For folks watching at home, that's Alt Enter Enter. All right, Control R 0. No, Control R, Control 0. There we go. Not intuitive.
Okay, so unprivate this and then inline it. Is the way we solve that one.
Inline this thing?
Yep. Yep. Okay, so this right line, this is, yeah. I think what's going on 410 is just the Sudoku board.print.
It has a toString.
It has a toString, yeah. I think that's the same thing. Let's find out.
I think it's going to be similar, but still fail. But I'm wrong. Okay.
Happy to be wrong on this one. Or happy to be right. Either way you look at it. I'm glad that is
I'm glad we're good bad copying it. So.
There we go.
And then this one, do you want to do the
same thing? Don't remove it. add it, shadow it. I wish this was an automated refactoring. Yep. There we go. And then delete it. I think it'd be interesting at the end of this to take a look at how many times we use lowercase and uppercase, considering that we are in a place where we have almost equal safety for both. Right? Because like our tests are so robust right now.
I'm not completely confident that our tests are robust, just because I think of all the times when I've tried to write combinatoric tests and there was some combination that mattered that I missed. Like, oh, you didn't ever call it this other way. And maybe with more practice, I'll decide that that's okay.
I'm feeling this is pretty good because every line is covered. But we could run like a mutation test against it. Okay, so now we have this 4443 or whatever, the thing where the board is on 43. That I think is a set value to 0.
It's setting it the dot.
Yeah, which is 0 for us.
That's something we specialized, right? If you set it, yeah. Nice. You have to set it to unknown.
Oh yeah, we actually did a.
Where is it? Right there. Oh, it's
maybe
private.
Public. And static on top of that.
You can't static a constant.
Oh, constants are static.
Technically, they're not static, but it doesn't matter for our purposes.
All right. Technically, they're not static because they're inlined at compile time.
Yeah.
Fair enough.
All right. So your question is, how close are we to making this thing
hidden? What just happened?
I inlined the variable.
Oh, okay. Thanks.
Very good typist. If I'm like, hey, you just sit back. I got this.
It's all good.
All right. So I'm looking for uses. There's a bunch of uses over there. We'll go fix them in a moment. And then there's this one, which I'm going to inline as well.
Yeah.
All right. Now we go back to test-based. So
this very much looks like we're doing another two-string.
We don't even have to write two-string.
No, I think this will fail, what you just did. Did that pass or fail? Oh, that passed? Perfect. Okay, never mind. What you said. I thought there was a new line in front of it.
And fascinating. So code takes the display, yoinks all of the special characters to make it into numbers. Oh my goodness.
And it's only done here.
I mean, I don't love what making this two-string.
No. Two code string is what we're going to do here. No, just undo for a second.
We'll get there. So.
No.
Okay, that broke it.
Undo. So what I want to do here is extract lines 88 through extract it as a method. Yeah, that.
Okay, I'm willing to do that. We have all of these values.
No, I know.
Are you just thinking that
just go with me for a second? I'm going to move it onto the board.
Okay.
To code string. Then inline it on 88. Or yeah, 80.
inline
inline
this
to
thing.
that, yeah. And then move the method to code string onto the Sudoku board in stack state.
Yes, make method non-static works here.
Perfect. Yeah. And now it doesn't matter that it's private and it's crappy, but it's encapsulated.
Okay, and so we'll just ignore it for now.
And when we finally delete, like once we finally get this board all in here, my goal is to delete it. Like, there has to be a way to do that.
Now more of these.
Yep.
This thing.
You have to do Sudoku board and stack state. Oh, I think I know something else.
Cool.
I'm just going to write that down on a sticky note so it's ready when we're ready.
I was going to optimize. Yeah, I could have.
Yeah, that's a set.
Oh, yeah.
Almost feels like we want a macro there.
Oh, like what?
Almost feels like we want a macro.
Yeah, we could sell it. What I really want is clipboard history.
Do you not have clipboard history?
Not on server.
Oh. Is that a security thing?
I don't know. My read of it is that server is just trails.
But you
desktop.
have clipboard history on your desktop.
That's true.
Did your clipboard history on your desktop not come from remote? Because it does for me. Because I have clipboard history on my Mac, and so I just grab it from that clipboard history.
Not how it works.
Also, for some reason, I think Visual Studio might have clipboard history. Or with ReSharper.
ReSharper does. Yeah. There it is. Okay. Thanks for the reminder. I'd forgotten about that because I've been using Windows.
Are we able to make board private yet?
I think so.
Okay, that feels good. Commit that. Okay, and so now that we made it private, we can make it however we want. And so what I want to do is make it instead of a char array, let's make it an int array.
And then change the toString to do the actual formatting.
Yes, exactly.
Okay, I'm fine with that. We still have the to code.
We have to change both of them.
Fix that up.
Yeah.
And then we could write a unit test for this class.
Yes.
For this particular concern. Should we write that test first?
We have it already. We already have
great coverage.
No, we have great coverage, but we also have the ability to create the board and print it. Like we have that coming in. It's like good enough. The new unit test isn't going to give us anything we don't have right now.
Okay.
So it's no more protection. It might give us intention, but I doubt it even gives us that.
Yeah. I mean, in general, I like that thing where we extract to the point where something is unit testable, but
I like that too. And when we have a unit test already that kind of tests the Sudoku board and stack trace and the toStringer. So what we're going to do here, no. So that's too much. So let's make a second board. So let's make a board. Let's rename board to board 2. Let's start there. An actual rename. Sure, that works. And then let's make a new private int. And for some reason, it looks like, I don't know if I hate that. Make a double array private int of yeah. Now, what I really, since we have unknown set to -1, it's 9 by 9. How would you generate a 9 by 9 stack of ones?
I will Google it.
That is an excellent idea. I feel like there should be something just like. I mean, at the very least, you could probably do a set and then set them all. Like, if you do a new 9 by 9 int array and then do a set all on it, is there something like that? I actually like that. If there isn't, let's make it. Is there a nice way of doing this already out of the box?
It's not jumping out at me.
Okay, so in that case, make a new int array 9 by 9. No, just like you're doing. New int 9 by 9. And then do dot set all. No, dot set all. And then pass it unknown. No, just unknown. All right.
Yeah. I think we're missing some things here.
Do you need parentheses or something?
That we can do.
You can't do 9 by 9? Yeah, array extension.
I don't
Oh,
think
wow,
so.
you're giving it a full name.
Because I knew you'd complain. There we go. Make me change it.
Yeah, set all.
Oh, it's void. No, it's not.
No, I wanted to return an int array. Yeah. And then you're going to do basically a for loop on it. You needed this array. Oh no, not the @ sign. If you can say that if you want to.
This and that? Okay.
No @ sign though. Get rid of that.
Well,
@ signs are ugly.
Should be called at this. We'll fight that another day.
We'll fight that another day. So then iterate through that. And yeah, so we're gonna need that dot length, and then we're gonna have to iterate through the j is gonna be that of I dot length. And then inside of here we're gonna say that of ij equals value. And then return that. So the thing is, if you scroll down, I think you can do, oh, that's interesting.
It's null.
Scroll down? Yeah, because it's that 9, try 9, 9.
Something different.
But this is a 2-dimensional array, right?
Yeah, and maybe that's what we want.
That is what we want. So let's do that like that then. And then also in the return value, wait, so you're saying that what's get length? Oh, dimension. Thank you.
How did I do this wrong? I bracket dot
No, I think it's just that get length
That
1. Yeah.
there.
Okay. And then you have to change line 53 to put a comma in the resulting type. How's that for a lot of cruft?
We're just learning programming here.
Totally faking by putting a capital R in there in the cheat space of refactoring. Introduce dead code. Okay, now in our set thing in here, if we scroll down, where we set the value, we have a set
I don't
value
know
on
where.
here somewhere. That now, yeah, do all that, but in the very first line, just say board. No, before the if, just board row column, not board two, board yeah, row column equals value. So that should now set it in both places. Why did that fail?
Out of bounds.
Oh, -1, -1.
Really? Are you sure?
Wait. Is it passing it? How is it out of bounds? What's the value that's out of bounds?
We don't know.
Ugh. Put a break. Yeah. Why does it not tell you the value?
3 and 11.
11.
11. That was more than I was expecting. Oh, because it's counting the display.
Display. Wow.
All right, let's delete this line so we can get back to green and then talk about what's next.
No. Don't delete that line. Keep that line in. So because it's fixing it in some weird way. Can we go to the places where comment it out for a second so that it's green? But keep it. I'm going to be right back here in a second. Go into find a place where set value is called. Yeah. So here, yeah, it's doing this stuff here, right? Where it's doing the row and then dividing by 9. That makes sense because the rows are at least all by them things. And then it's figuring out like this index. Yeah, it's like doing the math of the data structure here, right? So if we go back to where we were, the problem isn't going to be in the row. It's going to be in the column. So the row, get rid of the -1 on the row. And then on the column, you're going to say, like, what we need to figure out is how much cruft is in the thing, right? Are you on mute right now? Or did my...
Sorry, I was muted from coughing. The caller is calculating cruft.
Yes. We need to uncalculate it.
Really?
I mean, at this moment, yes.
Okay, well, we have that. I mean, that's what the caller was doing. So we can steal it from there.
And reverse it?
Yeah. Which I know sometimes we got to go backwards to go forward.
Yeah, we are going backwards to go forward right now.
Okay, let's see. So this is
and the
row without cruft.
No, but the row is the row.
Why?
Because there isn't... show our thing at the top. Oh, no, there is. There's middles.
Yeah.
And there's... Yep, you're right. And this is column without cruft. Yeah, this is us going backwards to go forward.
I hope we're going to go forward. I know we're going backwards.
That's good. At least we know the direction we're headed.
And then there's some reverse of this calculation.
So we take the row and we minus row divided by 3 minus 1.
There's no way this is right.
Well, maybe. Let's see if we comment that out. Does it still crash? It does. So can we do a really quick on line 226? Assert that row is between 0 and 9.
That row without craft is.
Yeah. Put the 0 on the... No, yeah, don't use the... Just put it on one line.
Well, I want to know which one is failing.
It won't tell you
separating them.
what row without cruft is.
Maybe.
Column without cruft. Yeah.
Oh, who called it that? Okay.
Sure. None of these are failing? We have a column -1 on line 232. Okay, it's still failing.
So that calculation that we saw that adds the craft, that's got to exist.
How is the debug.assert not failing?
I don't know. It is running.
But how does it get does debug, maybe we're not running in debug?
That's possible. So this is set to debug, but it's possible that ncrunch is set to release. I don't really remember where that is. So let's try running into the debugger.
Nine. That should have failed.
Because 9 is too much.
Yeah.
Okay, how come?
And what came in?
Oh, we're not using our newly calculated values.
Because we're idiots.
Did we fail the interview? I feel like this is an interview problem.
Okay, hey, this is good. This is good. Okay, so now let's go.
I want to pause for just a moment. The call site, there's a little algorithm that is to add craft.
Yes.
And I bet that happens in multiple places.
Oh, yeah, I'm sure.
And that it should be possible to extract that from all those places, which good, removes duplication, calls it out, and then write a corresponding remove craft function, and then test that the two of those produce matching results.
Yes, I actually do like that, but I think we're close enough that we don't need to do it. So here's my deal for you. If, like, in 5 minutes, all of this stuff isn't deleted, you call that back in and we'll do it. Because that sounds like a very nice, safe way of doing it. And I like it a lot. But I think we don't need it. But I have been wrong before.
This is that thing that we're often tempted with, like, oh, one more dune.
Yep.
No, it was 3 dunes ago.
So let's go, and we're just going to start with the code part, because I think if we're wrong, it will show up there first, and it'll be easier. So that print with code.
To code string?
Yeah, to code string. We're going to return here, instead of this, basically we're just going to, what's the easiest way to do this? So we're going to take the board. We just want all the values. Nice. There we go. And then,
So what I really wish I could do here is yield.
yeah, that'd be nice. But you
And
can't. But
almost
just put
can.
a string above it because we're just returning a string anyways. So if you want a string builder, that's fine too, but I don't care about this. And then here, say result plus equals that ij. Sure. And then return that. And this will break. So you're going to have to check for unknown, and because unknown right now is -1, we need to replace it with 0.
Mm.
Interesting. You didn't feel like you wanted to use the refactoring on that one?
Only after I started typing it.
Yeah. Okay. I definitely want to see how this breaks. Show me the...
Where are we going to run that? Remco, we need a right click and run approval. My context menu is having trouble opening.
Yep. Okay, here. So 90008, that seems good. No, wait. It looks, is there an extra 0?
Yes. So all of the, I think that the cruft became zeros in this view.
No, it's the same number
It's
of
too long.
things, right? It's not too long, is it?
I don't know.
Go to the end of this statement. What line are you on? Column are you on? 88. And the other one you're on 88 too, right?
Yeah, okay.
Yeah, when you see them side by side. So what's weird here though, look, because here we have a 0 and an 8 and an 8 and a 0. I think like oh no, we're missing digits. Like put those side by side.
Aren't they? What do you want me to do?
No, when you clicked on it again at the bottom of the screen, it was side by side. Do you see what I'm seeing at the bottom
okay,
there?
I see. Yeah.
And like at the things that are missing at the top are zeros, basically. But the things at the bottom are lots of numbers. So there's like numbers that we are not doing. Does that make sense?
So here's a 7 over a 0, and here's a 0 over a 7.
Like my question is, do we just have this in the wrong order, or are we missing data?
Here's an 8 that went. See, these got swapped. This is the wrong order.
You think it's the wrong order? Okay, let's go back.
But here's a whole bunch of zeros that don't exist.
But there's the easy way to
No, they
fix
do.
this. There's the easy way to fix this. So go back to the thing at the top and into our program thing. And so dimension 1 and dimension 2, let's rename I and J on 12 and 14 to row and column. Okay, and that seems logical. And now let's go down to the bottom part. We're still doing row and column, right? Where we set it. Okay, that, and then where are we setting it? Row, column, row, column. Yeah, so we're not doing something right.
I feel like we're in the
This is in the part where I feel like the thing you said we should do.
yeah.
So, yeah, let's do that. So, let's uncomment or comment. Go back to our like revert what we did in the as code.
Okay.
Or don't revert it, I guess. But
We
can
can
we get back
stash.
the old code? Yeah, basically stash. I actually want to keep this, and I want to get the old code, and I want to check if they're the same. Yeah,
So dot does become 0, but these special characters that go away.
go away. Okay, so now let's go back to the place where we convert this code, and let's run that test you were doing.
All right, tell me where you want to go back to the use of set value.
Yeah, the use of set value.
So the idea was to create a add cruft and remove cruft
Yeah, exactly. I
on
want to do
row
that now.
column.
But I thought we'd get it, and I was wrong.
All right, and that's this.
Oh, this is so weird. So we have a row and we have a column. And then we have a row to right and a row to column. And it almost feels like we just want to pass in here. Yeah, so extract that as a method.
What if we made a new set value that takes uncrufted row column and does the crufting internally? So basically move this statement into set value, but incrementally.
I like it.
So we got row right there and columns right there. So we're talking about set value
Direct.
without direct. Just be honest.
Without cruft. I'm good with that too.
Okay. Row without cruft.
Nah, just row column. Row column. Not that. That's just row column.
Okay.
And then calls. No, get rid of all
right.
This calls
right,
the other
right.
one. Oh, you need the value. And run this. Like that should still pass.
Yeah, I want to call it in one place.
No, yeah, but we'll get there. So commit. Wait, it's called in 0 places?
Right.
Sorry, I'm wrong. Call it in at least one place.
Right here. This might not be a good one. Yeah, that's not a good one.
It's a fine one. Go down. Keep row to right, keep column to right, but change line 69.
Yeah, they're reused down here.
It's fine. Change line 69.
But
you're not getting rid of these two.
Oh, okay.
You're just calling this one.
Move.
This is set value without cruft.
Yeah. Okay.
This is just row column. Or row to move. Yeah, column move. So run. Yeah, that's still working. Good. Okay. So now let's go find all the places where set is there. This is what happens when you mix your data in your display.
Yeah.
So
we're going to look for all uses of /3.
Sure. Why not just look for all uses of set value? Yeah.
So we do know that viable moves are crufty. We'll come back to those later.
We'll come back to this. Yeah. So right now we're just
All
set
right.
value without
Row to
cruft.
move is there, and row to right is not mutated again. Oh, this one we just fixed.
Yeah. So find other places where we set value.
Why am I not able to see other places where we call set value?
Okay. So set this to without cruft, and this is going to be row, comma, column.
We should, I'm glad we're starting to do this. The code is better for it. We should stop soon.
Yep. But hopefully not in the middle of this one.
It's better, not worse. No, better and worse. Net better.
Right now it's better and worse.
And now I like that we can
Delete those.
eliminate these.
Yeah.
Did anybody say anything in chat today?
No.
Why are we even here? Got an audience.
Huh?
I did my hair and makeup and everything. So I think this is another, yeah.
Yep. And this is row and column.
Expect this to pass.
There we go. Okay, and remove the cruft as well. No, remove, yep.
So I'm fine with doing both of those. Remove,
Yeah, me too.
especially because they're automated.
Yeah.
And passed. When do we stop?
Keep going. Yep, take them out. Not sure why it does that. But
Well,
it's like catching up to the fact that this is unused.
of course, I'm saying that, but it is gray on the screen. It knows well enough.
Yeah, it knows well enough that it's there. So it should. Yeah, maybe there's a message queue between gray it out and get the quick fix. Yep. So without cruft here, and it's going to be row to move, row to column to move instead of to right. And those stay around, so that's fine.
I can imagine a different context where we would introduce types for with cruft and without cruft row and column indexes to help the compiler drive this through. Because there's a real risk of mixing them up. We have tests today.
We have tests, and it's going to die soon. Like that is the, yeah. Oh, and now they're gone. So now you can clean them.
There were just two places.
I thought it was getting passed on or something. So the secret is hitting alt enter twice.
It's waiting. I actually spent like a summer doing something like this professionally. Temp row and temp column.
Yeah, that's so weird.
It must be for the weather tracking part of this application. Waiting for the test.
Mm-hmm.
Yeah, we had, it's like, it's looping. Finish. There we go.
And then we're going to do that again on 50. Temp and temp. And then we can get rid of the row to right and the thing.
Just gotta wait. Okay.
You're faster than the computer, Jay.
I've been impatient with computers for a long time. Okay.
Two references. Two references is good.
And one of them is our
us.
inline one. And this one is a viable move. And so we need to look at where viable moves are.
So annoying.
Because we have a notion here of a viable move that has a row to right and a column to right.
Yeah.
But they're only created in one place.
Where are they created? Yeah.
And you can see from the gray here, they're never set. So I kind of want to clean that up. But here's the one. And so this shouldn't be hard.
Yeah. So here where it says move to row to right, say row to move.
This is not a very safe way to do it.
We got tests.
We get tests. Yeah. In the real world, our beloved audience is thinking, well, what about I don't have
And
tests?
now we have to go to the place where we use viable move.
So one is in construction and the other one is right here.
Yeah. And this is going to be the set value without cruft. And we should be back to green.
Nearly as bad as I feared.
Good. Okay. There we are.
Getting bangs though.
And now we should be able.
We only have one call to this.
Which is us.
Yep. So we can inline.
Yes. That's a good way to do it. And then rename to just set value. And then we can
we should stop here. You're really looking forward to switching from the char array.
See the code still works. Just one more step. But you're right. We should stop here. I'm not disagreeing with that, but then we have to wait a week to know if that worked. So set on 23. Also set the int array. Because setting this isn't going to be a problem. Or should not be a problem. That should be green. Good. Commit that.
What is that?
It's just, yeah.
Unused data?
On data. There we are. And now let's use that down on the get code.
Okay, yeah, I can see why you really wanted to do that.
Yeah, because I'm not entirely sure. This is the, so you're going to make a string, you're going to make your for loop. Get all the rows, get all the columns. No, okay, sure. Oh, I think I know what's going on. Yeah, lots of swearing's going on in my head. So get the value here. Yep, put it in here with the concatenation or the ternary. Oh man. Not zero, not a string. Oh, yeah, I guess it is a string. The ternary won't work if it's a string. You have to make it an int, because otherwise you have double types coming back. And then return result, and this is going to fail. So rename I and j to row and column. Is it row and column? Are we doing row column?
Or reading why is this unhappy?
You need an extra curly.
One curly.
Yeah, so rename I and j. This is going to fail. Rename I and j to row and column. Did that pass?
Yes.
Oh, I guess it isn't. Wait, why would that pass though? This should not pass.
Why are you so sure it was wrong?
Well, because look, right now because we're cycling through the column. So we're printing out the columns and then the next row. We should be printing out the rows and then the next columns.
For the code string?
For the code string.
So remember the old implementation of the code string was just a select over the collection.
Yeah. But it still should be the case, right? That it's printing like the top row. And then like right now it's printing the column. It's printing this down, not over, which is weird. But it's working right now, right?
Mm-hmm.
Okay. It's weird, but okay. I guess it's a good place to stop. But you do understand what I'm saying, right? Like,
So
if the board reading right to left was 1, 2, 3, 4, 5, right? Yeah. I don't know why this works. That bothers me. But I'm also happy that it does work. Huh. We're going to have an interesting time doing the 2 string on the other one.
wait. I got this list from Willem. I can't remember your list, but I feel like
That's
they are.
fine.
They're like almost the same.
All right. So let's go to tools. Variable has a lag. There's also I almost feel like there's a need for a copy paste detector. We're not moving slowly, so I'm not worried about it at the moment. But if we were slowing down at all, I would pull that in.
Is that looking for code clones?
Yeah, so. It's looking for code duplication. We have resources, process, environment. Add domain in here because there's a lot of things that popped out today. So first of all, we have many duplicates of the data, right? We have that int array. We have a stack of int arrays. And then we have that's the thing I wrote down, which we never got to. I believe the only reason we hold on to that stack state at all is so that we can give the int array of the board as the final solution. And I think if we had a way of getting that from the board itself, we won't need to hold on to the stack. And the stacks are only used in the creation. And then stack state becomes its own little thing that's used to create the board in the beginning, but is not actually part of the Sudoku board. And the only thing we actually care about in the Sudoku board is now this double array of things, which, and you know what? In terms of language, I'm not sure I really understand the difference between an array of arrays and a two-indexed array.
It's whether the subarrays can be different lengths,
Yeah,
jagged.
where the one that is with a comma can't be.
Right. It's a rectangle.
Yeah.
But any number of dimensions, but yeah.
And there's some things that for just regular C# I want to pull out for what we had. Like the set all is nice. It would be nice to generify that. It would also be nice to allow you to pass in a lambda into it, right? So it's sort of like an XY goes to. None of that matters for this stuff. So like, I don't want to do it on this project, but if I was doing this in place where I would use it later, I would, and I'd probably pull it into a util package and make it actually like useful. Maybe that's something that should jump into the approvals utils package.
All right. So we tried a thing. We there was a thing there where we said, let's try to uncalculate the Cruft numbers, and
then
didn't
we
work out, and we backed
stopped,
up.
and then we backed out, and then we were going to go a different direction, and then we backed out again. So let's
Where does that
first
go?
record that. Just process. So this was in the pull out Cruft. So the first thing we did is we just tried to do it, which I blame on the fact that I just watched Sandy Metz do a similar thing, and we had really good tests. That's so unfair. And then that did not work, so we backed out. And we were going to do the property-based test that you were suggesting, which is we have a function, we have an inverse. Let's make the inverse function and check that both of these do it. But the moment that I sort of said, hey, let's do that, you said, no, I don't want to do my own idea. I have my own idea. So then what we did is we wrapped it where we just moved the calculation into here, which I like that. It was an elegant solution. Then we were able to move everything into that. That was also nice because this Cruft is it's being forwarded, right? Like there's still something with Cruft that we didn't delete. We deleted a lot of it, but there was one thing that was getting passed on to another method. Right. And then like that move guess is now nicer. Like move and column and row actually mean what you would expect it to mean in that stupid little guess thing. There's a lot of places where we're still doing like a single array of 1 to 81 where we doesn't make sense where we're in there dividing by 9 and then or like that should just be rows and columns double array. Yeah. It's weird. It's really, really weird to me that the code does this in the wrong dimension. But like, it also means that like, because this is an 81 array, like you're dividing by 9 and you're dividing by 9, right? But we don't know which way that's happening. And it must be happening in many, many places consistently for this code to work. But maybe not the way we think. Right? Like it's a... Can we go look at that text file?
The output?
Output. Yeah, we have a huge test file. If you open up unit test over on the side.
I can expand it.
Yeah. and then go to the test method one, yeah. And then scroll down to where, so here it says, if you look at the code is 9000008, right?
And
And
then
that,
08. Yep.
and that is the rows.
Mm-hmm.
Oh no, sorry, it is doing it. Okay, so that is a single row, and then we're iterating through the columns. All right, that makes sense. That is what I was expecting. Okay. I was just confused in the way to print it. Because I was thinking XY, which is the opposite of row column. Okay. All right, to jump back to that makes sense now. That'll make me feel better for the rest of the week. Yeah, and so we sort of like shadowed the method, and then we collapsed the method in.
Mm-hmm.
That was a nicer solution, right? Simpler, easier to write, and the temporary stuff went away quicker.
The thing that I really like about how that went for us is that we tried one way and found the point which we decided was too hard, and we were able to go back and find an incremental way.
Yeah.
It wasn't that one of those approaches was the right approach and one was wrong. It's that we didn't get so caught up in one that we weren't able to realize when it was time to switch to smaller steps.
Yeah. I like that too. I actually like Claire McRae. Very often I want to do things, and Claire is like she just rolls her eyes, and like she has this thing where it's like, you always think this is 5 minutes, but it's always like an hour and a half. And so like I think there's like a little Claire on my shoulder when you were like, wait, this probably will be easier, and I'm like, let's try 5 minutes. But then we would usually set a timer, right?
Mm.
Because then like when the 5 minutes goes, we can sort of reevaluate. And so I was looking at my clock on the desk, and when the 5 minutes sort of went, I'm like, yeah, this is a bad. This was supposed to already be solved, and now I'm more confused than ever. Yeah. Yeah. I'm starting to understand what this code does. Like we're now, this is our third 90 minutes. So we're like 4.5 hours in, and I feel like I kind of get what the code is doing. It's weird because we're back in. So we started today with saying, yeah, this is not where the interesting thing is. Let's go to the other place. That's where, let's see. And we went to the other place, and we're like, oh, we got to fix where we came from. Right? Because like now we understand that enough. And I'm starting to feel like it's so weird. Like just uncovering this one little section is really helping to see what the other pieces do, even though we've still not looked at a huge part of the code.
Mm-hmm.
Right? Like we understand how, because we're sort of sectioning off the piece that the data that's getting manipulated. Like in the end, like this board is the thing, right? So if you know how it's being used, how it's being changed, even if you don't see how the thing that's changing it is making its decisions, right? You get a sense of like, is any of these words making sense? So like, if we notice that this drawer keeps getting opened and food comes out of it, then we can start saying like, well, whoever's doing that must be hungry. Like when they're hungry, they go into this drawer and they pull out the food, right? And so like, it's that kind of thing, right? Like it's, yeah. Other insights from today?
If I had them, I forgot them. This is good.
All right.
I feel like we had more insights today.
Yeah,
I
like
mean,
stuff is
more.
coming together.
Yeah, well, like what we put on this retro, there's more to put on here.
Yeah. Oh, you're saying like we lost things.
No, I mean like.
By the way, it passes in a solved board. Like we should write that process down in the domain. So it generates a completely full board, and then creates a puzzle from that, and then solves the puzzle, Wait, I still that doesn't make sense. Still, why it gives you the solve solution? Because it looks like it is actually solving the puzzle. It sort of said like this needs to go because of this.
So it's almost two programs. It's a Sudoku puzzle generator and a Sudoku puzzle solver.
Yeah,
And if you're going to write a solver, it's going to need an input. So you may as well write a generator.
I mean, I guess so. Sure. Yeah. Okay. I mean, it's kind of interesting in that respect, right? Like it can create puzzles for you and solve them and show you how to solve them.
Mm-hmm.
Yeah. Hmm. All right. Same time next week?
I think so. Let me just double check that. Yeah.
All right. I'll see you then.